हेलो एवरीवन, जय जगन्नाथ। कैसे हो आप सब लोग? आई एम सोमेश चिलाओ, वेरी मच एक्साइटेड टू एक्सप्लोर chemistry world with you. So welcome to my channel. I'll be here. So let's start today's topic, reaction mechanism. What do you mean by reaction mechanism? Reaction means a substrate converts into product. That means a reactant converts into product. In which pathway it follows? That means which path it is followed by. So to study about the pathway, we study reaction mechanism. So let's start. You know that in a reaction, a reactant converts into product. That means in a reaction, the old bond of the substrate break down and a new bond formation occurs in the product. So you know that this reactant how converts into product. That means which pathway it is followed. Genuinely, if he will come in daily life, if a admin hai, if a student hai, so he will go to school. He will go to school. So he will go to school. How he can travel to school daily? So basically, this admin can go to school by car. He may also travel by bike, and he may also travel by walking. So there are various types of pathway in reaction mechanism. So let's start. What are the pathway? So this pathway is divided basically three types. One is ionic pathway, one is radical pathway, one is concentric pathway. So in your syllabus, only ionic pathway we will study. This radical pathway is only studied under photochemistry, and this concentric pathway is studied under pericyclic reaction. Okay, so let's start the ionic pathway. What do you mean by ionic pathway? Ions means charged. That means it is followed a charged complex like species. So ionic pathway is of four types. First one is substitution reaction, second one is elimination reaction, third one is addition reaction, and fourth one is acid-base reaction. Okay, so basically we will start in this lecture substitution reaction. And what do you mean by substitution reaction? आजकल तो बहुत सारा सब्स्टिट्यूशन होता है, आप सबको पता है। लेट्स एक बंदा, इस बंदा का एक बंदी है, एक बंदी, ये लड़के ये लड़की है। So you think if another लड़की will come, if another girl will come, then if it will substitute this girl, then it is called a substitution reaction. that means one will come and replace other, one will come and replace other, that is called a substitution. So if we will study in the reaction mechanism, this part is called a substitution reaction. Okay guys, so let's go to elaborate substitution reaction. How many types of substitution reactions are there? So basically substitution reactions are of 6 types. One is SN1, SN2, SNI, SNNGP, SNA and SNEA. So SN1 means the superscript 1. Superscript 1 means it is unimolecular substitution reaction. Okay. SN2 means bimolecular substitution reaction. SNI means intramolecular substitution reaction. SNNGP means neighbor group participation substitution reaction. And SNA and SNEA, these two types of reaction are basically seen in aromatic substitution reaction. That means it may be electrophilic and it may be nucleophilic substitution reaction. And this SNEA substitution reaction, that means it is benzene intermediate. It follows by benzene intermediate. Benzene intermediate. So what do you mean by benzene? Do you know the structure of benzene? This is benzene. This is benzene. Who can say what is the hybridization of this carbon? Who can say? If you can say the correct answer, then comment in the box. Okay. What is the hybridization of this carbon? So substitution reaction. That means in the substitution reaction, one substrate is present. That this is Rx, and a nucleophile will come. Then a nucleophile will come, and a solvent medium is needed, and a product or ionic group will form. So why in a reaction a solvent is given? That means a solvent is given in a reaction to make more feasible of a reaction. So Rx, this is substrate. This is substrate and this is nucleophile. This nucleophile will come to the substrate and make leaves the Levy group X minus. And this is the product. This is the product. Okay. So basically we will study what is substrate, what is nucleophile, and what is solvent. Step by step we will discuss about this. So let's start. What is substrate? Okay. So let's start. What is substrate? What is substrate? Substrate means there are various types of substrate like Rx. X means halogens, fluorine, chlorine, bromine, and iodine. Similarly, ROH, ROTS for OMS, RNH2, ROR. This is ethyl disulfide. Okay, this is ethyl. Similarly, what do you mean by R? R means alkyl. It may be 1 degree, it may be 2 degree, or it may be 3 degree. Okay. So let's come to the second concept, that is nucleophile. What do you mean nucleophile? Sometimes we are confused that which nature of nucleophile. That means it is either electron rich species or electron deficient species. So the nucleophile, from the word nucleophile, I divide into two terms. That is, one is nucleo and one is phile. Nucleo means nucleus is positive charge in nature. Nucleus is positive charge in nature. And phile means loving. Phile means loving. So ऐसा reagent जो कि पॉजिटिव चार्ज को लव करेगा, obviously it must be electron rich in species, electron rich in nature. So nucleophile nature is electron rich. That is, it is electron rich species. So electron rich species. What do you mean electron rich species? That means electrons are so much concentrated on the nucleophile. So nucleophile is of two types. One is neutral and one is charged. That means in neutral nucleophile there are one pair present. There are one pair present. Similarly in charged, that means anion species. In the anion species negative charge is present. जैसे कि OH minus, NH2 minus, C3 minus, and etc. So how can we decide the strength of nucleophile? There are various types of factors which affect the strength of nucleophile or nucleophilicity of a nucleophile. That means it may be size, it may be electronegativity, it may be steric hindrance, and it may be also solubility. So these are the factors which affect the strength of nucleophile. So come to point number 1, size. How size may affect the nucleophilicity of a nucleophile? So let's start size. So let's come to size concept. How size may affect the strength of nucleophile. So here is a substrate, here is a 2 degree substrate. Let's say it is a 2 degree substrate. And there are two types of nucleophile or two types of anion is present. One is larger in size and one is smaller in size. Its size is larger. That means its polarizability is more. Polarizability more होता है तो its tendency to donate also increases. If you cannot understand this concept, so come into a real life. In genuine life, how we can understand the size concept. So let's take an example. If there is a box, here is a box, I draw the box, and there are two types of students are standing. One is taller in height and one is smaller in height, and they are catching two balls in their hands. So you think who can donate or who can throw the ball into the box easily? कौन बॉल को आसान से एक बॉक्स के अंदर फेंक सकता है? कौन? He is taller in height and he is smaller in height. Obviously, that taller in height, he can donate the ball or he can throw the ball into the box easily, but he feels difficult to throw. Similarly, if the size of anion increases, then nucleophilicity also increases. So we may conclude that size of anion direct proportional to nucleophilicity. That means if size of anion increases, then nucleophilicity also increases. So let's take example. If here is OH minus and here is SH minus. So whose nucleophilicity is more? That means whose strength of nucleophilicity or nucleophile is more? Obviously, in between oxygen and in between sulfur, in between oxygen and sulfur, whose size is more? Obviously, the size of sulfur is more, so its nucleophilicity is more. Similarly, I minus, bromine minus, and fluorine minus. That means iodide, bromide, and chloride. Whose nucleophilicity is more? The size of iodine is more than bromine, and the size of bromine is more than chlorine. So obviously, the nucleophilicity already is. Then come to second point, electronegativity. How electronegativity concept affects the strength of nucleophile. So you may be confused in two concepts, size and electronegativity. So how you can know where size concept is applied and where electronegativity concept is applied? So size concept is applied from top to bottom in a periodic table, but electronegativity concept is applied through a period. That means from left to right. So electronegativity concept. Let's come to electronegativity concept. So what do you mean by electronegativity? Electronegativity is a term. That means it is the tendency to attract the electrons towards it. So if it will attract the electron towards it, can it donate electron easily? No. If it will attract the electrons, towards it. If it attracts the electron towards it, it cannot donate easily. Okay. So if electronegativity, so the electronegativity inverse proportional to nucleophilicity. That means if electronegativity increases, then nucleophilicity decreases. Similarly, if electronegativity decreases, nucleophilicity increases. Let's take an example. CH3 minus, NH2 minus, OH minus, and chlorine minus. You know that from left to right in a periodic table, electronegativity increases. Similarly, among the four, the electronegativity of fluorine is more. So that if electronegativity of fluorine is more, then nucleophilicity decreases, and carbon is less electronegativity in nature. So the nucleophilicity of carbon, that means C3 minus, is more than NH minus, then NH2 minus is more than OH minus, then OH minus is more than fluorine minus. Okay, so this is the order of the nucleophilicity. Let's come to next concept, stability. How stability can affect the nucleophilicity? Before going to this concept, I share you one thing. आपने कभी IIT बाबा की रील्स जो स्टेबिलिटी वाला रील्स है कभी देखा है? अगर नहीं देखा है तो जरूर देख लीजिए. After watching that video, you can understand the concept of stability. So how stability affects the nucleophilicity? You think if one gets stabilized, can it easily move or can it easily donate? No. If one stabilized, then is lesser in energy. You know that stability inverse proportional to energy. If its energy is less, the stability will increase. So let's take an example. OH minus, that is hydroxide ion. This is acetate, CH3CO minus, this is A, this is G, and this is phenol ion. Do you know what is the structure of phenol ion? So you think which is more energy, and which is less energy? This is naked ion. The negative charge is only present. On oxygen. So it is more in energy. because here is no resonance stabilized. But in the B and C option, here the negative charge is resonance stabilized. Here the negative charge of oxygen is resonance stabilized. I make the isotopy again. You can understand. And in this thinner side anion, the negative charge on oxygen is resonance stabilized by also carbon atom. So here the negative charge comes only in two oxygen atom, but here the negative charge comes in oxygen as well as in carbon. So you know that the energy order obviously A is more in energy. So between B and C, you decide which energy is more. Which energy is more. You know that the negative charge here only on two oxygen atom, but here the negative charge comes on oxygen atom as well as in carbon atom. In between oxygen and carbon, which is more electronegative in nature? Obviously, oxygen. If negative charge comes on oxygen, then it is more stabilized than carbon. So obviously, its energy is more. That means energy of C is more than B. This is energy order. The stability order is, so stability order is reverse. Obviously, it's reverse. That means stability B, then C, then A. If one gets more stabilized, that means it cannot donate easily. So I may conclude that stability is inverse proportional to nucleophilicity. Nucleophilicity. That means once stability increases, if once stability increases, then the tendency to donate decreases. That means nucleophilicity decreases. जैसे कि C3COO minus. This is acetate anion. So acetate anion stability is more. So the energy is less, then nucleophilicity also decreases. Let's come to next concept, steric factor. What do you mean by steric factor, and how steric factor can affect the nucleophilicity or the strength of nucleophile? You think if one is sterically clouded, then it cannot donate easily or it cannot move easily. That means if steric hindrance increases, then nucleophilicity decreases. That means steric hindrance is inverse proportional to nucleophilicity. In genuine life, I take an example, then you can understand better. Let's take an example. Think here is two types of pipes. One is thick in nature, one is thin. One is thick in nature, and one is thin in nature. One is thin in nature. So here is an ant present, and here is also an ant present. So here sugars are present. You know that ants are so much attracted toward the sugar. So you think which ant can easily move between the two pipes? Obviously, this pipe is thick in nature, so it is less crowded. Less crowded means it is more empty. So he can move or he can donate easily through this pipe. That means if steric hindrance decreases, then nucleophilicity increases. So this is the concept of steric factor. Okay. So let's come to solvent. What do you mean by solvent? I said that solvent is a medium which makes the reaction feasible. So solvent is of two types. One is polar solvent and one is non-polar solvent. Polar means polar in nature, non-polar means no charge. That means chargeless. So non-polar example of non-polar solvent. Hexane, C6H12, hexane, carbon tetrachloride, toluene. These are the non-polar solvent. And polar solvent. What is polar solvent? Polar solvent is also two types. One is polar protic and one is polar aprotic. What do you mean by protic? What do you mean by protic? Protic means it must have an hydrogen atom which is directly attached to a most electronegativity atom. That means, let's take an example. Methanol, CH3OH. So here is the hydrogen which is directly bonded to the most electronegativity atom oxygen. So it is polar protic in nature. If we will discuss about polar aprotic, so it must not have that type of hydrogen which is attached to highly electronegativity atom. Example, acetone. This is acetone. C3CO3. Here there is no hydrogen. There is no hydrogen which is attached to oxygen. So this is polar aprotic in nature. Okay guys, so in this lecture we concluded how the some factors like size, electronegativity, stability, steric factor, solvent can affect the strength of nucleophile. In the upcoming video we will discuss the most appropriate concept, that is SN1 and SN2 reaction. Okay, so in this video we conclude that I think you may better understand. If you get some information and you get some valuable knowledge from this video, then subscribe my channel and like and share. Jai Jagannath.